Okay, so a body starts from rest and accelerates to a velocity of 5 meters per second in 20 seconds. So let's segregate the motion into parts. Are you all there?
Yes, please.
A body starts from rest, so initial velocity 0, and accelerates to a velocity of 5 meters per second. The difference is that here we are given the final velocity. It accelerates to 5 meters per second in a time of 20 seconds. So the difference is that we don't have the here we don't have the rate at which the body accelerated, but we have the final velocity. But if we are to calculate, that is easier. V minus U on T. V is 5, U is 0, T is 20. So 0.25 meter per second squared is the acceleration. Class, are we okay?
Yes, please.
Good. It maintains this velocity for 10 seconds. So during the second part of the motion, we are told the velocity is maintained. So U is equal to V, and they are all equal to 5 meters per second within a time of 10 seconds. Here, join it. U is equal to V, and they are all equal to 5 meters per second.
Mr. Edia,
Hello.
please, I don't get it.
Where?
From where you got the acceleration at 0.25?
You see,
1/4.
1/4. And what is 1/4?
0.25.
Yes, that's it. Are you okay?
Please, yes.
Okay. Then the third part of the motion, we are told it decelerates to rest. Okay, so U V it decelerates to rest. 0.
Mr. Edia.
Hello.
Mr. Edia.
Hello.
Please, how are we getting the 0.25 from?
Okay, so let's see. We are given the initial velocity. We are given the final velocity. But the rate at which the body accelerates, we don't know. And that's what we are looking for. So A is equal to V minus U all on T. The rest, what is V? V is
5.
5. What is U?
0.
0. What's the time? What's the time?
20.
So we have 5 on 20.
1/4 or 0.25.
Hey, so that's what I have here.
No, I was asking that why are we finding that? Because the first time we didn't do that.
Yes, the question didn't ask, but I am teaching, so I'm explaining to you if there is a need for us to find out, that's how to go about that.
Okay. Thank you very much.
Okay, so acceleration right, with a time graph. So we have to draw a velocity time graph. Sketch, please. This is a sketch. If you are asked to draw, you have to use maybe a scale drawing on the graph, or you take a scale and then do it. Now this is just a sketch. So just this velocity axis, time axis. My minimum time is 0. It will be here. Time of 20. Then followed by time of 10. Then finally another 10. So this is 20, 30, 40. Are we okay? My maximum velocity here is 5. So within the time interval from 0 to 20, the body accelerates uniformly and attain a final velocity of 5. So there's it. The initial is here. Then the velocity is maintained for a further 10 seconds. There's it. Then it decelerates uniformly to rest. So let's join the points within 10 seconds. Let's join the points. We have this, this. Okay, once we have straight lines, this is a uniform acceleration. This is zero acceleration. This is also a uniform deceleration. So that's the velocity time graph. Okay. Now the sub questions. Calculate the initial acceleration. Good. Already.
Sir.
We are even asking the question to calculate the initial acceleration of the body.
Okay.
Which would use the equation to calculate, but we can still use the graph. But the slope of a velocity time graph is equal to the what? The slope of a velocity is equal to the acceleration.
It will be 12. Sorry, 5 minus 0 over 20 minus 0.
So the same value. Okay. Let's also calculate for the deceleration. Let's find the deceleration. Do that for me. What did you do for the deceleration? Yes, what did you get? Hey, Happy about my Kosia, Resi, Juvia. What did you get?
Negative 1 on 2.
Negative.
So that is negative 0.5 meter per second squared. Okay. When we use the equation, we have A is equal to V minus U on T. And what is U? V is 0 minus U is 5. So the same thing, time interval 10. All right. Then we have to calculate Calculate the total distance covered by the body. The total distance covered by the body. Okay. Let's use the trapezium rule. So total distance can be obtained using the area of this trapezium. What is A? A is 10, 30 minus 20, so 10 plus B is the whole 40. H is 5. So we have 25 by 5. And what is 25 by 5?
125.
125. If we segregate this into parts, area 1, area 2, area 3. A1 will be equal to half, the base is 20, the height is 5, which is equal to 50. Area 2, the length will be 10, the breadth or the width is 5, another 50. Area 3, the base is 10, the height is 5, this is 25. This plus this is 100 plus 25, 125. Okay. Then,
Yes.
if we use the equation of motion, so either we are using the equation of motion or the graph. If we want the first distance coming, the distance in the first part of the motion, half ut.
Mr. Edward, please, you can
Hello.
see the other side of the screen.
You are okay, then finish writing before I continue, okay? Rather finish writing. But when you finish, please draw my attention, okay?
Yes, please.
We build
Mr. Edward, please, I'm done.
to be our home.
Mr. Edward, please, thank you so much.
Welcome.
They have no voice.
Who is that in the orchestra? Singing. Mhm, mhm. All right, so let's use the equations of motion. So it's s plus half at squared. The motion starts from rest. And there's another caveat, and that is we can also use v squared is equal to u squared plus 2as to find once there is an s, which is distance. We cannot either use this or that. Even if in the first part of the equation we have v, we have u, we have t. And so we use that to determine acceleration. Once we have acceleration, we can find the distance. So let's make as the subject from here. We have v squared minus u squared on 2a. U is 0. V is 5. So 5 squared on 2 times 0.25. So 25 divided by, this is 2 by 25 over 100. So 25 on 50 over 100, which is the same as 25 on 1 times 100 over 50. There's this, so 50. Okay, so the distance covered is 50 meters, as we got using the first part. So this is also giving us the same thing. Let's look at, oh, are you writing?
Yes,
You are writing.
Yes, please.
And if you are writing, just, you don't need my calculation without calculator. You can use your calculator to do the same thing. So just put them together and get your S, okay? Then the second part of motion, U is equal to V, and they are all called 5 meters per second, and the time is that. So if I'm using this, ut plus half at squared, because acceleration is 0, then all this part goes to 0. Constant velocity. So S is equal to U, which is 5 by T 10. And this is also equal to 50 meters. If this is 50, the last part, U is 5, V is 0, T is 10. So if we are to use, I'm coming. So if we are to use S is equal to UT plus half AT squared. Earlier, we calculated for the acceleration, and then we had minus 0.5. Let me put minus half or minus 0.5. So S is equal to U 5. The time is 10 plus half by the acceleration is also minus 0.5.
So the minus 0.5 is the deceleration.
Exactly. Yes. Okay. So we have 50 minus 100 on 4. Okay. So this part is 25. 104 is 25. 50 minus 25 is also 25. Are we okay?
Mr. Gia,
Hello.
please, the question still calculates the initial acceleration,
Yes.
and that is the negative 0.5 meters
No,
per
this is
second.
the final acceleration, which is a deceleration. The negative 0.5 is the final acceleration, which is a deceleration. But the initial acceleration is the 0.25. Are you okay?
Okay, thank you.
So let me adjust the screen. So okay. Yes, it's even there.
Thank you.
So everywhere you go, you can be connected because each of the methods would give you the same results. Okay. Because the assignment I
Mr.
gave you.
Edward,
Hello.
please, what have you written at the last side?
Come again.
I don't see the word.
Let me send the screen to that part of the board for you.
It's not okay. It's like, yes, please.
Are you fine?
Yes, please, I will meet you. Thank you.
Class, a reminder of the database I'm collecting. The deadline for me to present my data is tomorrow. I know a lot of you have responded to my call. Please, if you haven't, do so today or evening, because I have to present it tomorrow. And I need, if you are a GEHE student, I need your name, info, and then your class. If you are not a GEHE student, I need your name, info, and your school. Okay. I know a lot of you have sent that to me, but I'm talking to those of you who haven't made time to do that for me. Do so. My deadline for presentation is tomorrow. Please, is that okay?
Yes, please.
Yes, please.
Secondly, please, I do upload videos. When you visit the page, subscribe, okay? Subscribe, and then at least if the lesson actually meets your expectations, you can like, you can pass a comment and then share so that the online session can be famous, or I mean have that visibility. Okay, I'm hoping to do a lot. I'm hoping to do a lot of Form 1, Form 2 topics so that anytime you miss a session, you just go there and then, I mean, revise. So, because yesterday I gave you a lot of trials, Please, I want you to use the time again to go back and reflect, because today's lesson will be a remedial for a lot of the questions which featured yesterday. So I won't add on. Use today, go through it, and then master. I'll send another possibly on Thursday, Friday. Okay, by then I'm sure you'll be well armed with the nitty-gritties of all this, so you can apply effectively. So I'll not add on today. Go over and then master. And within Friday, Saturday, I'll give you a challenging one. So you apply all the necessary skills to overcome this challenge. So until we meet again, same time.
Mr. Tia,
Okay.
Mr. Tia, please, why did you find the zero? Okay, thank you.
Okay.
Thank you.
Please, if you have any questions, quickly ask before I sign out. If you have any questions. All right. So in the absence of any further questions, probing, addition, submission, this is where I draw the curtains on today's show. Until we meet again, same time, tomorrow or no, next week. Next week. In fact, take care of yourselves and bye-bye.
Bye.
Bye.
Okay.